Okay, we'll start our class. First, we'll study about rocks and its classification. After that, we'll study about earthquakes. Then after that, we'll see about the tectonic plates. So, okay, is my slides visible to you all?
Yes, sir.
Yes, sir.
Okay, so thank you. Yesterday, we studied about all those universe, latitude, longitude, time zones, the motions of the earth, and about all those seasons. So, any doubt in that, anyone? Okay. So, today, we'll start with rocks. See, yesterday, in some parts, we forgot to cover about the composition of whole earth. So, inside the whole earth, see, in yesterday classes, we covered the composition of crust. That in composition of crust, we have oxygen as highest. So, oxygen we have 46%. But whereas in composition of earth, we have iron as highest. Just a minute, let me set up the filter. Okay. So see, in composition of whole earth, in that iron is the highest. So remember the first four one. However, I will share the slides. So iron highest. Iron have 35%. So in the composition of whole earth, we have iron as highest, and while composition of only that earth crust, we have oxygen as highest. So these two questions have come already. So don't forget, in whole earth it is iron, and in the crust, only crust, we have oxygen as highest. Then we have silicon 28%, aluminum 8%, then iron 6% in composition of crust. But whereas in composition of whole earth, we have iron as highest, then we have oxygen, then silicon, then magnesium. So, okay, just be clear with this one. So, okay, now we'll study about the rocks. What is rocks? See, rocks are that particles. See, what is happening? Now, group of some elements is there. Suppose now we can take it as iron. So, these are group of elements, iron, oxygen, then silicon. So, these are group of elements. So, these group, sorry guys, there was a power cut connection. So, due to that, there was network issues. Okay, is my slide visible to you all?
Yes, sir.
Okay. So, now what is rocks? That group of minerals that is held by chemical bonds, that is known as rocks. So important rocks, we can see that now in that rocks, we'll study about the rocks in later stage, that what is sedimentary rocks, igneous rock, metamorphic rocks. So in that rocks, like if you'll see here, you can see here, minerals like feldspar and quartz, they are the minerals. So they are common minerals, they are found in one part. So that particular solid part is known as rocks. The scientific study of rocks, we call it as petrology. The scientific study of rocks is known as petrology. So based on that mode of formation, now rocks is divided into three parts. That is igneous, sedimentary, and metamorphic rocks. So igneous rocks is small. That suppose now there is convectional current inside the earth. Now we study about the layers of the earth, that mantle, crust, core. So now if you see inside the earth, if you take the half part, here we have crust, then we have mantle, then we have core. Then in the crust, that whole crust part is only that lithosphere. Then some parts of the mantle, upper parts of the mantle, some like 5 kilometers. That whole part is known as lithosphere. Then some parts that below the lithosphere and in upper mantle, that is asthenosphere. And this asthenosphere is in molten state. It is neither liquid nor fully solid. So in that off of this one, this our whole earth is maintaining their equilibrium. Now our whole earth crust is on top of the asthenosphere. So the one concept you must know, that it is isostatic equilibrium. isostatic equilibrium. This about isostatic we will study in the mountain part. Isostatic equilibrium. What is happening now? This our earth crust is maintaining that equilibrium. Now we are on the now whole earth crust is on the this molten part, that highly viscous part, that is neither liquid nor solid. Means you can take that liquid. So on that liquid, our whole earth crust is maintaining. So that how it is able to stay. Say inside the water, if we go, we will be able to fall down. So on that liquid, this earth crust is maintaining that equilibrium. So that equilibrium is known as isostatic equilibrium. So because of that only, our whole earth crust is staying up of the liquid. So this is about. Now inside this earth crust, we have our convectional current. In mantle, we have lot of radioactive material. So that active materials, they have their thermal difference. Some radioactive materials have some other thermal conductivity, then some have some other. So due to that, what they are trying to come out of the earth crust. And since some of these are not able to come, so they are forming the convectional current. So due to that, they are trying to come above the earth. So earth crust. So when they will come, that particular part, they're coming as, like you can say it as volcanoes or that folded mountains. So that particles, when that is coming up of the earth crust, and they're settling down, cooling down and settling down. See, inside the earth, that molten part is known as magma. That volcano takes place. So inside the earth crust, that is magma. But when it comes up, that is known as lava. When it comes up, that is known as lava. So once that lava is cooling down, so that is becoming into the solid part. So that lava is known as igneous rocks. So that solid parts formed from the lava, that is known as igneous rocks. And after that, what happens? Now again, suppose again volcano occurs. So what will happen? This solid part will be somewhat far away. So now that will be cooled down and it will be somewhat far away. Again, up of it, if volcanoes took place, then up of it, some other parts will take place. So now some new parts will take place. So that will be forming layers. So once it will be forming layers, and due to our activity like wind action or heat, that sunlight, so due to that there will be some erosion in that. There will be some erosion in that earth crust, that lava part. So in that time, what will happen? That will be forming some layers. So that particular layers are known as sedimentary rocks. So sedimentary rocks are formed from the igneous rocks, the result of deposition of fragments of rocks. So the result of deposition of fragments of rocks is known as igneous rock. And metamorphic rocks, they are formed from the out of existing rock undergoing recrystallization. That means you can say, suppose there are some wind action or something. So after it is, now if wind is coming, so some small particles it is taking and it is placing in one part. So that parts that is from both of the igneous rock and sedimentary rocks. So when it is settling down at some place, so that rocks are known as metamorphic rocks. So metamorphic rocks is a form of formed from the both igneous and sedimentary rocks, and sedimentary rocks is formed from the igneous rocks. Okay, what is known as rock cycle? See, inside rock cycle, what's happened? Now suppose this is earth crust. So from here inside we have volcano. Now it is that all materials are coming and settling out this side. So this is first one is igneous rock. So first one is igneous rock. Then after that, due to some actions of wind or sunlight, that is forming into layers, and that rocks is known as sedimentary rocks. Then after that, what is happening? After that, again the action of wind, then sediment or that falling into some other, then it is forming into the metamorphic rock. Then metamorphic rock, what will happen? That will be like, you can say it will be somewhat smooth, because it is the recrystallized part of the sedimentary rocks or igneous rock. So that will be somewhat smooth. Then after that, what will happen? Suppose if there is some activity, Then after it, once again, if it subsides inside the earth crust, then what will happen? Due to the pressure and temperature, that once it goes inside the earth, then that will become in the molten state. That due to high temperature and high pressure, that will become in the molten state. So now igneous and metamorphic, they are reversible. So once it is subsided inside the earth crust, so that will become molten state. Then again after that it will erupt as volcanoes or mountains. So that again when it comes up of the earth, then it will come into the igneous rock. Then again that igneous rock will come in sedimentary cycle, sedimentary rock. So now that is rock cycle. So rock cycle is a continuous process through which old rocks are transformed into new rocks, new ones. So igneous are primary rocks. So don't forget, igneous rocks are also known as primary rocks. And this question has come in the UPSC Civil Services prelims exam. They did not ask about the igneous rocks. They asked about the primary rocks. So don't get confused. That primary rocks is also known as igneous rocks. Igneous rocks can be changed into sedimentary or metamorphic rocks. The fragments derived out of igneous and metamorphic rocks form into sedimentary rocks, and sedimentary and igneous rocks themselves can turn into metamorphic rocks. So that is rock cycle. See, now in rock cycle, so types of rock: igneous, sedimentary, and metamorphic being. In rock cycle, what will happen? That the small particles due to lithification first it will form in igneous rock. Then again igneous rocks will change to sedimentary. Then sedimentary due to high temperature and high pressure it will turn into metamorphic. Then again once it goes inside the earth, is subsidized under the earth, then it will turn into magma. Then again it will come as a form of volcano. Then again it will turn into igneous rock. So that igneous rocks is changing into sedimentary rocks by weathering. By weathering process is what? Like that's what I said about this wind action or sunlight. So that is weathering process, or you can say that our human activities also. So that is also a weathering. So through that rock cycle is maintained. Okay. Now you can see here. Here igneous is changed into sedimentary by weathering and erosion. Then sedimentary is changed into metamorphic by high heat and pressure and also weathering and erosion. Then again metamorphic when it subsides under the earth by melting, again it becomes magma. Then once it comes out of the earth as volcanoes, then again it will turn into igneous rocks. So in that same way also sedimentary, that is not that only metamorphic rocks get subsidized under the earth. In some process sedimentary rocks also get subsidized. Then again the sedimentary rocks will change into the, after cooling down, again change into the igneous rocks. And igneous rocks also can directly come into the change the form to metamorphic rock. So that is the rock cycle. So now about igneous rocks. See, a study about the examples of rocks, that examples of igneous rocks, sedimentary rocks, metamorphic rocks, that all the names I mentioned in the slide. So just go through, because in a exam they might ask that granite is an example of which type of rocks. So, or basalt or gabbro. So like they might ask. So just remember about that thing. And you know that in continental crust we have granitic rock, that we will study when we are studying about the plate tectonic. And in oceanic crust we have basaltic rock. So don't forget, the basaltic means basaltic, this is basic. So that basaltic rock is in oceanic crust, and granitic, that is in acidic, that is in continental crust. The solidification of magma formed from the first rocks on the earth, that is igneous rocks, that we studied, formed out of solidification of magma and lava, igneous rock, primary rocks. And this igneous rock is unfossiliferous. What is happening now in this? Now igneous rock is coming out of the earth in like volcanoes, or that coming in the form of volcanoes, in the form of lava. When it is cooling down, in that there are no fossils. So that buried parts are not there. That is coming in voltage from down of the earth. So there are no fossils. So because of absence of fossils, that is known as unfossiliferous. So igneous rock is unfossiliferous. And similarly, metamorphic rocks is also unfossiliferous. See, metamorphic, now from the metamorphic rocks is formed from the igneous or sedimentary. It is formed from the igneous or sedimentary. So what is happening, that smooth particles, that tiny particles that are due to some actions of the anthropogenic activities or wind action or sunlight action or by some erosion or weathering methods. So by that that particular rocks is turning into the very tiny particles, or you can say as dust. Then after it is cooling down, it is becoming metamorphic rock. So metamorphic rocks also is unfossiliferous. They don't have any fossils present on the metamorphic rocks. So igneous rock is unfossiliferous. So okay, now we have studied here that this silica, this igneous rock, in acidic it is silica, and basic igneous rocks are both silica and igneous rock is both in acidic. What is happening, that we have the presence of silica, and also in basic little amount of silica is there, and also that more amount of basalt will be there. So more amount of basalt will be there, and some amount of silica will be there in igneous rocks. So on the basis of chemical composition, igneous rock is divided into two parts, that is acidic rock and basic rock. Acidic means presence of silica, and basic means little or no amount presence of silica but presence of basalt. So that is basic rock. Okay. So now what is on the basis of this inside the earth, that type of rocks? So this igneous rock is divided into two parts, that is intrusive rocks and extrusive rocks. So intrusive rocks means what? Inside the earth, and extrusive means outside the earth, that is at the surface of the earth. So extrusive, that is surface of the earth, and intrusive, that is inside the earth. So inside the earth, that rock is known as igneous rock, and outside the earth, that is intrusive igneous rock, and outside the earth, that is known as extrusive igneous rock. So granite, gabbro, and basalt, they are the examples of igneous rocks. So there are three types of igneous rocks based on place and time, taken in cooling of the molten matter, that is plutonic rocks, volcanic rock, and intermediate rock. So about the volcanic rock, now we have studied here, due to that outcoming of lava, that hot molten magma is coming out of the earth, so that is cooling down. So that is volcanic rock. So there are two types of rocks based of chemical composition. That is acidic and basic. Okay. Now examples of igneous rock. So just remember all the examples of rocks, that particular igneous rocks, and if they're changing into the sedimentary rocks, that igneous is changing to sedimentary, then that also you must know. Igneous is changing to metamorphic, that also you must know. Sedimentary is changing into metamorphic, so that also you must know. So in igneous rock, we have the example of granite, basalt, gabbro, andesite, diorite, obsidian, pegmatite, peridotite, then tuff, scoria, rhyolite, and pumice. Remember this name, rhyolite. This name was asked in, I think so, either CDS or ASCAT question in 2021 or 2022. So remember this name, rhyolite. Okay. Now this intrusive rocks. So intrusive rocks also known as plutonic rocks. So what is happening, if magma cools slowly at a great depth, minerals formed in the rocks may be very large. So what is happening inside the earth itself, if that magma is cooling down, like inside the earth means some upper part, that magma is cooling down. See, we forget, see here, now from the earth volcano is taking place, but some particles inside the earth itself, they are cooling down and they are forming that solid part, that is also known as rocks. So what is happening here, we will study about the silts dying, then that plutonic rocks, that everything we will study, we have that again, we will study there. So that type of rocks, when it is cooling down inside the earth itself, so that is known as plutonic rocks. So that plutonic rocks is also known as intrusive rocks. So these rocks appear on the surface only after being uplifted or denuded. So what will happen? Suppose if that upper crust will denude denudation will take place or some upliftment will take place, then that time only some denudation or upliftment. Upliftment means what? This part will go up due to some deposition, or this part will go down means that is submergence. So in upliftment or in denudation, that time only we will be able to see it means intrusive igneous rock or plutonic rocks. So that is intrusive rocks or plutonic rocks. So that is inside the earth itself, it is cooling down. See, when it is coming out of the earth after cooling down, that will become smooth and small. And inside the earth, so when it is cooling down as a larger part, as a crystal, so that is known as intrusive rock. Here we will study about that in intrusive rocks, all those rocks we will study. So remember about all those parts what we are studying. See, if that particular rocks is cooling down, that particular magma is cooling down inside the earth, and they are spreading like in this, like in horizontal direction. So in horizontal direction like this, if you are there cooling down, and like this if they are, so that is known as batholith. You can also call it as Pluton or something. So that is known as, remember the batholith name. So that horizontal rocks that has cooled down, and they are the downest part. So when they are cooled down, that is batholith. This is batholith. Now see, inside the earth, when that lava is coming up, so it will have some part like this or some part like this, it will coming out, then some branches will be going on. So in that, what will happen when that rock is taking place as a saucer shape? So remember this name also as a saucer shape. So that saucer shape rock is known as lopolith. That saucer shape is known as lopolith. So if saucer shape comes, means that is lopolith rock. And when that shape, that is in this type of shape, like anticline and syncline. So if the shape is in anticline and syncline, that is known as phacolith. So that rock is known as phacolith. So remember about the locolith, batholith, phacolith. If that is an anticline and syncline type, so that is phacolith. Or suppose, say, remember about the instead of saucer shape, they might also ask that name of concave type. So remember that name also. So that concave type is locolith. And then this anticline and syncline type. So that is phacolith. So anticline and syncline related to one more term, that like you can say that when we are studying this part, you can say that compression or rarefaction. So in that we have the anticline and syncline. So that also remember. So anticline and syncline, we have the phacolith rock. And suppose if the form, what is happening now, it is coming up like this, and it is settled in the dome shape, as a dome shape. If it is settled, that is known as lacolith. So remember that if the dome shape is there, then that is lacolith, and if saucer shape is there, that is locolith, and if it is in horizontal direction, then it is batholith. Means what, it is lying down on the rock surface. So that is batholith. And if so remember this horizontal, this don't get confused with seal. See, because seal, what is happening, once that volcano is coming up, then from in the inside the earth, in horizontal direction, in horizontal type, as a branch, it is coming out of the earth. So that is known as seal. And when it is in vertical direction, it is known as dike. It means a vertical direction, it is straight. So that is dike. So batholith is lying down on the ground. So don't get confused that horizontal means it will be batholith. So horizontal as a branch, if it is coming, that is seal. And batholith is lying down. So that is batholith. And dike is vertical part in that inside the earth, that is pulled down as a vertical part. So that is dike. So this is all about lacolith, phacolith, locolith, batholith, seal, and dike. So don't forget these names. Okay. Now acidic rocks and basic rocks. So acidic means what? Acidic or silica content will be higher. That is up to 80%. So in acidic rock we have quartz and feldspar. So examples of acidic igneous rock are quartz and feldspar. The rest is divided among aluminum, alkalis, magnesium, iron side, lime, etc. So 80% is silica and 20% is all these rocks. And they have lesser content of heavier minerals like iron and magnesium. So hence they are less dense and are lighter in color. So acidic rocks are lighter in color because that heavier minerals are not present. These rocks constitute the CR portion of the crust. So upper crust we have the CR. So these rocks constitute the CR portion of the crust. And basic rocks means what? It is oceanic crust. So yesterday we studied that you can say that consists of seema. So it has the density as same of mantle. So remember, so oceanic crust, so mostly oceanic crust are of basic rock. So these rocks poor in silica and magnesium content is up to 40%, and silica content is only 40%, not more than that. And the remaining is spread over iron oxide, aluminium, alkalis, potassium. So that is basic rock. So due to low silica content, the parent material of such rocks cools down and thus flows and spreads far away. So this flow and cooling give rise to plateau. So mostly all those plateaus are of basic rocks. So even you can say our Deccan plateau. So that is basic rocks. And presence of heavy elements imparts to the rocks a darker color. So heavy elements like iron, magnesium that are present, so that give the dark color. And not being very hard, these rocks are weathered relatively easily. The examples are basalt, gabbro, dolerite. So basalt, gabbro, dolerite are examples of basic rock, and quartz and feldspar are example of acidic rock. So that was about the acidic rock. Now we will study about the sedimentary rocks. So sedimentary means what? You can say a strata rock or layer rocks. So sedimentary rocks are formed by the lithification, so consolidation and compaction of sediments. So that sedimentary rocks are formed by the lithification, consolidation and compaction of sediments. So hence, because of this lithification, consolidation and compaction, these are layered or stratified of varying thickness, like example sandstone or shale. So these are known as sedimentary rocks. So sedimentary rocks are a result of denudation, that is weathering and erosion. So ice deposition on sedimentary rocks are called as till or tillite. So till or tillite we studied in that sea floor spreading theory also. So remember about that one. So till or tillite means that is glacier part. So glacier part means mostly ice type. So till or tillite are ice deposited sedimentary rock. And wind deposited sediments are known as loess. So remember, loess is a deposition landform and till or tillite is a deposition landform of glacier, and loess is a deposition landform of wind. So depending on upon the mode of formation, so sedimentary rocks are divided into mechanical form, organically formed, or chemically formed. So mechanically formed means what? It is physically formed. So that is sandstone, limestone, shale, conglomerate. Then organically formed means what? They have the content of some organics, like you can say as presence of some minerals, or you can say presence of like silica, some organic, like in organic chemistry you might have studied that bonding type. So that presence is known as organically formed. Then chemically formed. So chemically formed are limestone, halite, potash, and organically formed are gasterite, chalk, limestone, and coal. So remember this, even that mechanically formed sedimentary rock, or organically formed sedimentary rock, or chemically formed sedimentary rock. So remember that also. That okay. Now important sedimentary rocks are breccia, calice, chalk, chert, then diatomite, limestone, dolomite. Remember all these names. See, all these sedimentary rocks, what is happening? They are impermeable. See, now this lava is cooling down and igneous rocks are in longer part. So longer part means what? If it is a larger part, so that water might percolate. But it is due to the erosion and weathering, if that is becoming into a smaller particles, so it will be settling down without leaving any gap. So because of that, if there is no gap, so that is impermeable. So they are impermeable. Mostly they are impermeable. Okay. Now these are the characteristics of sedimentary rocks. So they have the presence of fossils. So they are known as fossiliferous because they have the fossils of plants or animals. They hold the most informative geological records due to the mark left behind by various geophysical activities, that is wind, water, biological activity. So due to that, due to biological activity or wind, water, they have the presence of fossils. So they are known as fossiliferous. So one is sedimentary rocks is known as fossiliferous, others all both igneous and metamorphic are unfossiliferous. So these rocks are generally porous and allow water to percolate through them. One is now see they have the fossils. So one is some parts they allow water to percolate. So remember they are generally porous. So this is all about the sedimentary rocks. Okay. Now metamorphic rock, we studied that is recrystallization and reorganization of minerals, that by some weathering or erosion if that taking place and it is settling down. So that is metamorphic rocks. So in this what will happen, that minerals will get arranged in layers or lines. So such an arrangement is known as foliation or lineation. So that minerals arrangement in layers or lines is known as foliation or lineation. So remember this process. So what are the causes of that metamorphic rock? So why it is metamorphism? The organic movements are there, that mountain buildings. So that means what such movements often take place with an interplay of folding, warping, and high temperature. Suppose now if two plates are converging each other, so there will be fold. So if there will be fold, then there will be some breakages or something inside the mountain. So because of that some particles are breaking down and that are falling down somewhere. So that is due to organic movements. So orogenic. Oro means what? Mountain. And genic means building. So orogenic movement. So that is mountain building movements. That is also the cause of metamorphism. Then lava in flow. So the molten magnetic material inside the earth crust reach the surrounding rocks under the influence of intense temperature. So that lava, once it is coming out, so again that solid rocks, when that high temperature, high pressure is pushed on them, so again they will form into that smaller particles. They will start breaking. Then if again that particular temperature and pressure is, then they will become molten state. But before that process, when it will turn into smaller particles as a smooth dust, I can say, so that is due to lava inflow also causes of metamorphism takes place. Then geodynamic factor and forces. So that is omnipresent of geodynamics such as plate tectonics also play an important role in metamorphism that we have seen. So this is all about metamorphic rocks. So some important metamorphic rocks are marble, anthracite. So anthracite is a part of coal, that is made up of coal. Then gneiss, then hornfels, maricosite. So all these are the metamorphic rocks. Slate. So remember all these names. This is phyllite. PHYLLITE. So this is phyllite. So question. All these are metamorphic rocks. Then with increasing temperature and pressure, so that metamorphic rate also will increase. So now see, now that slate, you turn these are all the metamorphic rocks only. Then due to that increase in temperature and pressure, slate will turn into phyllite. Then that phyllite will turn into schist. Then schist will turn into gneiss rocks. So remember all these rocks names. So even that metamorphic rocks also will become the trace metamorphic rocks after due to high temperature and pressure. So the higher the metamorphic rate, the more change the rock will be form its original form. That rock will be more changed from its original form. So all these rocks are shown here. So see that particular examples that rocks are changing into how it is changed into the metamorphic rock. So that igneous or sedimentary rock, that granite due to pressure it is changed to gneiss. Then clay or shale, so due to high pressure that is changed to schist. So remember this gneiss or schist name also. That they are found in the older landforms. So about gneiss and schist. So granite is changed to gneiss, clay is changed to schist, sandstone is changed to quartzite. clay is changed to the slate or phyllite, coal is changed to the anthracite or graphite, then limestone is changed to the marble. So all these due to some influence that are given. So remember all these names. If they change into metamorphic rocks, then what is the name given to that particular? So this is all about the rocks. This is all about the rocks. So if any doubt in rocks, you can ask from me.
Sir, can you explain the isostatic equilibrium once?
Okay, one. Okay, see what is happening. Are you all able to see the new slides?
Yes, sir.
Okay, see. Now we'll take some parts of the our. Suppose this is the one part of the earth. So here in upper part, this is earth crust, then this is mantle, and this is core. So in this earth crust, we have the lithosphere. So in that lithosphere is between the full crust, and also some upper part, upper mantle, that full consists of lithosphere. That is fully lithosphere. Then we have the asthenosphere in the upper mantle, that is below the lithosphere. So this is the asthenosphere, and this full part is lithosphere. So what is happening? This asthenosphere, this is in molten state. So that molten state, or you can take it as in liquid state. Molten means what? Not fully liquid or not fully solid. But okay, since this full mantle now it is, this is also in molten state. You can take it as in liquid state, that molten state. So up of this in liquid state, now up of this our lithosphere is staying. So now lithosphere is there. So suppose inside the water, if you put some material up of inside that up of water, then its density will be high. Then it will submerge into the water. If density will be less, then it will float on the water. So what is happening now? This density, our earth crust density is less. Whereas you can see in the case of mantle, so that density is more. So this both asthenosphere part is the part of mantle. So it has the highest density. So up of that molten state, or you can say it as liquid state. So up of that liquid, we have our earth crust that is fully on the upper part of mantle. So that is maintaining some equilibrium. Without maintaining equilibrium, that much part, how can it stay? That also in the balanced manner. So because of that balancing manner, so that balancing is known as isostatic equilibrium. So in that due to isostatic equilibrium, our earth crust is floating on the molten part, or you can say the liquid part. So that is isostatic equilibrium. So it is maintaining the isostatic equilibrium. So any other doubt? So are you now? Did you understand?
Yes, sir.
Okay. So that was about the rocks. So now we'll study about the earthquake. So earthquake means what? Now the sudden movements inside the earth, that after some time we are seeing on the earth's crust, that is known as earthquake. So that sudden movement is known as earthquake. So earthquake is of two types. One is natural and one is man-made. So that natural earthquake is what? Volcanism. That sudden, if there is sudden forces acting inside the earth due to convectional current, we have our volcanism. So due to that sudden force, when it is trying to come up. So due to that, once it is trying to penetrate the earth crust, so due to that sudden movement, we'll have our shaking in that nearby places, or to nearby to that particular location to some places. So that is known as earthquake. So that due to volcanism also, that is natural process. So due to volcanism also we have the shaking. So that is earthquake. Then due to the movement of plates. Suppose if we have our plate. Now see, we have many plates. There are 7 major plates on this earth and 22 minor plates. So what is happening? That major plates or major minor plates. So when they're both, see, all plates are moving here and there. So when they both either converge to each other or diverge to each other, then there will be some movement. That plate movements will be there. So suppose if they are converging, so that plate movement will be there. So because of that also our earth will shake. So that is due to the plate tectonic, that is a natural cause. Because of that, if that plate are converging or it is diverging or it is transforming, so that will take the place of some sudden forces inside us. So that will make that upper part of the earth to shake. So that is known as earthquake. So in plate tectonic, there we will study about the convergent plate boundary, divergent plate boundary, and transform plate boundary. So that we will study in the plate tectonic types. So there we will study there about these boundaries. See, convergent means what? Means converging plates. Then divergent means diverging plates, and transform means they are just due to friction force, means just they are doing the lateral shifting. Then man-made are that nuclear test, means what? If we have seen that nuclear bomb dropped on Hiroshima or Pokhran, so due to that nearby places also had that particular shaking. So that is also a earthquake. Then building of dam. So building of dam, how it is making means what? Now dam or reservoirs. So what is happening, that all that sources of water that is coming and sitting down at one place. So that is putting the lot amount of pressure on the earth crust. So due to that, again that temperature will be, due to that high pressure, again that inside the earth there will be some shaking. So due to building of dam also, there will be some shaking of us. So due to that, there will be earthquake. So see, now in Koyana, that is in Maharashtra. So due to this also we had this earthquake, and also see Three Georges Dam, that longest dam in China. So because of that also we have earthquake in our area. So that all that nearby places, because of building of dam also, earthquake also occurs. So okay, about this earthquake, that about focus, epicenter and hypocenter, that we study in the later part. Okay, other we will see here. See what is happening. Suppose this is the earth crust, and if there is some sudden shaking of the earth, then from inside the earth, when sudden that forces will be produced. So that particular, that from which place that forces is produced, that place is known as focus or hypocenter. Focus or that place is known as hypocenter. And once through that, now through that liquid part, once it is coming off of the earth part. So when it is coming nearby the earth crust, and there it is producing that shaking of the earth, so that place is known as epicenter, that 90-degree angle. So 90 degree to focus or hypocenter, there we have the first shaking. So first shaking we have at this place only, that is perpendicular that place. So there we will have the epicenter. This region is known as epicenter. And after that, that due to that sudden shaking, then we have at some other places also shaking. Then again that speed will be keep on decreasing. So remember about the epicenter name and focus and hypocenter name. About this portion I have come already. That if it is inside the earth, that is focus or hypocenter, from which that sudden shaking took place, and that sudden shaking after taking place when it is coming directly to 90 degree to the crust part. So that to crust part when it is coming, that is known as epicenter, where it is felt first. So that is epicenter. So at this place only it is that earth shaking is felt first. So okay, now this earthquake is that focus, due to that focus that is taking place. So that because of that depth is divided into three parts. So depth we see it as three parts. One is known as shallow depth, that is shallow focus. That focus is shallow focus. Then intermediate focus. Then we have the deep focus. So shallow focus, that is from the earth crust 0 km to 70 km. Then intermediate focus, that is 70 to 300 kilometers, and deep focus is 300 to 700 kilometers. So mostly on the earth crust, we have that earthquake felt now day by day, or in Japan also you can feel. So that is 70 to 80% is felt by the shallow focus earthquake. So mostly all that focus is in the shallow area. So that is shallow focus earthquake. So these three are the three types of earthquake based on the depth. Now see, our earthquake, how it is measured. See, so
Sir?
earthquake, tell me.
The slide is not changing, sir.
Okay, now is it changing?
Yes, sir.
Okay, this is the part of that room change part. So in this we don't have the pent-up processes. Okay, so see, this part you all understood now. This part in this types of earthquake. Okay, about the depth. So we study about the shallow focus. We study about the focus or hypocenter and epicenter. So this one is the focus, that inside the earth where it is felt first. So that is focus. So due to the sudden movement, we have our fault. Due to sudden movement, there will be some crack or something inside the earth. So that is fault. So that fault at some places where it is felt first, that is known as focus. So that, and perpendicular to it, that 90 degree is known as epicenter. Focus is also known as the hypocenter. And on the basis of depth, there are three types of earthquake. So there are shallow focus earthquake, immediate focus earthquake, and deep focus earthquake. So shallow focus is 0 to 70 kilometers, that is 70 to 85% earthquake happens here. Then in intermediate focus, we have in intermediate 70 to 300 kilometers, that is 12 to 15%. Then deep focus, we have 3 to 5%. So these are all about the types of focus on the earth. So these are all the types of earthquake. Now we will study about the earthquake measuring. So just wait a minute. Let me change this slide into the pent-up type. Okay, here is my slide changing. Anyone can you confirm me? Anyone?
Yes, sir.
Okay. So see here we are studying about those earthquake, natural and man-made. Then here we are studying about the epicenter, focus, then depth. On the basis of depth, types of earthquake: shallow focus earthquake, intermediate focus earthquake, then deep focus earthquake. Then now we'll see about the earthquake measuring types. See, so earthquake is measured on the basis of a scale. It is measured by Richter scale. So scale is that on the basis of a scale, it is measured by Richter scale or Mercalli scale. So that Richter and Mercalli scale, on the Richter scale, we are measuring the magnitude of the earthquake. So magnitude means what? Energy of that sudden shaking. So that how much energy is produced, that we are measuring by the Richter scale. That is magnitude. And intensity means damage. So that is intensity of earthquake is measured by Mercalli scale. So that is range from 1 to 12. So that is range from 1 to 12, and where on the Richter scale it is range from 0 to 9. So that here energy is measured, and on Mercalli scale intensity of the earthquake is measured. That is intensity means how much damage causing to the human parts or that building and everything. So that is intensity, and that intensity is measured by the Mercalli scale. And instrument we are measuring the earthquake, that is by seismograph. So instrument we are using, that is seismograph, and but that other scaling parts we are using, that is Richter scale and Mercalli scale. So don't get confused that Richter, Mercalli and seismograph. So seismograph is the instrument, but inside the instrument we have the both Richter scale and Mercalli scale. So that Richter scale, by Richter scale we are measuring the magnitude of earthquake, and intensity we are measuring by the Mercalli scale. So see, on this this Richter scale is measured by the 0 to 9. So here what is happening? Suppose this 1, 2, 3 lines if you are taking. So here it is, that is, suppose if here it is 10, or you can say this 1 means it is 10 to the power 0. So that is 1. So after that what will happen? From here to here, that magnitude gap will be 10 to the power 1. So that will be multiplied. So here on the 2 part, here we will have 10 to the power 1. Then again, and the third magnitude will become, it will be keep on increasing. So 10 to the power 3, then 10 to the power, 10 to the power 2, then 3. So like this, by multiplying into 10 times, it will be keep on increasing. So that in that way, that magnitude measurement are written. So in that we are missing. Suppose if it is 4 means 4 magnitude is what? That is 10 to the power 3. That is 1000. So that magnitude of earthquake is 1000. So by Richter scale we are measuring the magnitude, and by Mercalli scale we are measuring the intensity of the earthquake. So now earthquake. So network of seismograph. That seismograph is a instrument that is used to measure. So the network of seismograph stations all over the world record dozens of earthquakes every day. So we have dozens of earthquakes, but that is not that much damaging, or it does not have that much magnitude. So means what, it is coming like 10 to the power 1 or 10 to the power 2. That type it is coming. So it is okay, normal. Most of them are not felt by human beings as they are minor quakes only. The occurrence of severe earthquake is limited to a few regions in the world. So that severe earthquake, like it is coming to a few regions. Or that is like, suppose this Nepal earthquake that came in 2013. Not 2014. That Nepal earthquake that came in 2014. So that time we have that shaking in the northern India, some parts, and in Nepal. Then now recently Turkey. So in that particular parts that will have the severe earthquake. So the point within the earth's crust where an earthquake originates is called as the focus. So what is your focus? The point within the earth's crust. So inside that earth's crust where that earthquake is originating, that is focus or hypocenter or seismic focus. So this is focus. Now see, and that generally lies within the depth of 6 kilometers. So that is within the depth of 6 kilometers. And the point vertically above, that is vertically above, or you can say that it is exactly perpendicular or 90 degrees. So that is known as epicenter. So on the earth crust where that sudden earthquake is felt, that is epicenter. But the intensity of earthquake will be highest in the epicenter and decreases as it moves away. All natural earthquakes takes place in the lithosphere, the region which constitutes the earth crust and rigid upper part of the mantle. So the lithosphere you all studied means what? Fully crust part and some parts of the upper mantle. That is lithosphere. Okay. Seismic waves. See, now this seismic waves, when it is produced, so that will be in the circular manner. So in that circular manner, is what will happen? It will produce some faulting lines. So when it will produce some faulting lines, so what will happen at the epicenter? Epicenter will have our this shaking, first shaking. What during that time what will happen when it is shaking? So to the that means straight to that faulting line will have a faulting on the upper part. So that will lead to some faulting is what? That land might do the epicenter land might be subsidized, or sometimes it might rise up on this part, might go down. So that faulting will take place in this place. So from here, suppose if this is epicenter, then from here if we make angle, so that is 30-degree angle. So remember that. So earthquake waves or seismic waves. The earthquake which originates in the lithosphere propagates different seismic waves or earthquake waves. So earthquake waves are of two types. One is body waves, and another one is surface waves. So in body waves is also of two types. Body waves is what? That is inside the earth it is taking place. So body waves means inside the earth. Suppose this is the earth crust. So inside the earth crust, when we are having that seismic waves, that is known as body waves. And when it is coming to the surface, when it is felt, so above the surface it is known as surface wave. So here we have surface wave, and inside we have body waves. And body waves is also of two types. Body waves is of two types, that is P waves and S waves. So that is primary waves and secondary waves. So that P waves, what is happening? When that first we have that sudden shaking that primary waves is felt in all three states, solid, liquid and gas. But whereas secondary waves, it is felt only in the solid parts. And surface wave is also of two types, that is log waves and one is log waves and one more is Rayleigh waves. That we will study in the later coming part. See, so on the basis of depth, we studied shallow, intermediate, deep earthquake. Then of the total energy released in the earthquakes, about 12 to 15% comes from the intermediate earthquake, and about 3 to 5% comes from the deeper earthquakes, and about 20 to 85% it comes from the shallow earthquake. So that also we studied. Okay. See, what is happening? Why we have Pacific Ring of Fire? See, there are many places on the earth, major place, minor place. So what is happening in the Pacific Ocean side? Why we don't have the settlements there? Because there are many minor places located in the Pacific Ocean, and due to that only this Pacific Ocean is shrinking day by day. Actually, it is said that Pacific Ocean is moving, means what? It is extending, but due to the presence of all those minor places, forming of trenches is taking place. So due to forming of trenches, Pacific Ocean is shrinking day by day. So Pacific Ocean, we have lot of places, minor places, major places. So because of that, there are daily earthquakes coming on that particular place. So, and also volcanoes. So that Pacific Ring of Fire is formed. So that Pacific Ring of Fire accounts for about the 68% of all the earthquakes on the earth. A second belt known as Alpine belt or Himalaya or Alps belt. So mostly now see inside the earth, on the earth crust, here we are seeing in the Himalayan belt side that earthquake, or in this earth side that is in Europe. So that like in Turkey side. So there we are seeing the earthquake. So that is Alpine belt. So second belt, first we are having the Pacific Ring of Fire, that is 68%. Then second belt is Alpine belt. There we have the 15% of the earthquake totally. Then mid-world mountain belt, Alpine belt extends parallel to the equator from Mexico across the Atlantic Ocean or the Mediterranean Sea. That is Alpine and Caucasus ranges. So in this Alpine belt also we get the Japan. This Alpine belt means what? It is a large range type. So the Japan side also. This Japan side, why we have a lot of earthquakes? Because it is near the Pacific Ocean. So this Pacific Ocean side, we have a lot of earthquake, and that even it happens in the ocean crust also earthquake. So because of that, Japan receives lots of tsunamis. So that is due to that earthquake inside the water. And the third belt is mid-world mountain belt, that is Alpine belt. That also extend to the Mediterranean Sea, Alpine, that Caucasus mountains. So that will be locating where that Caucasus mountain is there. That will be locating on map in later stage. So see, this is the distribution of earthquake. Mostly that earthquake will be in the nearby the water bodies. So see here. Here we have the Rockies Mountain, and here we have the Andes. So see here that the highest belt is there. Then from here only this belt and this belt. Now suppose now the earth is in a round shape. So when will fold, then this belt will come here. It will join here line. So here we have Pacific Ring of Fire. Then this Himalayan area. Then here we have that Caucasus Mountain and Alpine, that Alps Mountain. So here we have lot of earthquakes on the earth. So see, in Turkey we had this earthquake, and this was due to the Anatolian plate and Arabian plate. So this was due to transform plate boundary. Here what happened? That Anatolian plate and Arabian plate both were sliding towards each other. Means what? There was a lateral type of shaking. So because of that, earthquake was there in the Turkey side. So that Turkey, now since it has come in recent, so remember these plates names. That is Anatolian plate and Arabian plate. That is transformed plate boundary shaking of these both plates. So due to that, we had earthquake in this region, Turkey region. So earthquake seismic two types: primary, secondary waves. And this primary can travel in all three types of medium, and seismic can travel only in the solid. Then we have L waves and Rayleigh waves. So body waves we studied, that is in two types, and that is inside the body. So this is all about the primary waves. Let primary waves, when it comes, it will be in the compression and expansion type. So it will be what it will be. It will compress. It will compress. Nice. Then there will be some expansion. So nice. There is a direction of wave propagation. So okay, primary waves are the fastest waves, and they are also known as longitudinal waves. See, since now here we have seen that compression and expansion is there. So they are traveling in the parallel side. So they are as parallel. So they are known as longitudinal wave or compression wave, because here in diagram see we have compression also. So now it will be compressing or expanding. So that all with that those waves traveling in parallel way and they are compressing and expanding. That is known as D waves. So they are also known as longitudinal waves, and they are of the high frequency. They are high frequency, but they are the least destruction. They are inside the earth, so they are the least destruction, and they travel in all medium, that is solid, liquid, and gas, and they have the speed of 5 to 8 kilometers per second. Then secondary wave, that is the second fastest wave, and this is transverse wave. Secondary wave is the transverse wave, and P wave, that primary wave, is just 1.7 times faster than the secondary wave, and this secondary wave is somewhat destructive because it is traveling in the solid medium. So if it is traveling in the solid medium, then that time what will happen? There will be that stress inside that solid medium. Then that particles, since that secondary wave is supporting shear stress, primary wave does not support shear stress, but this one is supporting shear stress. So what will happen? That particles will start moving. So due to that, there will be some fracture or faulting inside the particular material. Then this is all about the secondary wave. So this secondary wave should be traveling in the like anticline or syncline, you can say. So that is known as transverse waves. Okay. So surface wave, that is that occurs on the surface of the earth. There are the two types, love waves and Rayleigh waves. So here in the surface wave, what will happen? It will move like this. So it will produce crest and trough. Crest and trough will be produced, and then they will be the perpendicular to the wave propagation. So they are known as surface waves. There are two types, love waves and Rayleigh waves. So love waves, what happens? This kind of surface causes horizontal shifting of the earth during an earthquake. So when that horizontal shifting of the earth will take place, that is known as love waves, and they have much slower than the body waves that are faster than Rayleighs. So they exist in the presence of semi-infinite medium by overlaying the upper finite. Means what? When there is earthquake, they are moving some parts in horizontal direction. So that is love waves. Confined to the surface of the crust, love waves produce entirely horizontal motion. So they produce entirely horizontal motion, and Rayleigh waves, they follow in the elliptical path, like in a spiral, you can say, nice wave flow. So they flow in the both horizontal and also in the vertical path. So they cause the highest damage on the earth's surface. But where love waves, they travel on the horizontal motion, so they don't cause that much damages, but they shift the land. But where these Rayleigh waves, they are both in horizontal motion and also the vertical motion. So a Rayleigh wave rolls along the ground just like a wave rolls across a lake or an ocean. So mostly these Rayleigh waves we have mostly in the water bodies. Because it rolls, it moves the ground up and down and side to side in the same direction that wave is moving. So see, now we have in this way, means what? It is also moving, it is moving forward, so it is moving side to side, and also it is moving up and down. So up and down and side to side, we have that in the Rayleigh waves, that movement. Then most of the shaking felt from the earthquake is due to the railing waves. So on the earth, what we are feeling that shaking, that is due to the railing waves. Now we are coming to last part. See about the shadow zone, and remember about the shadow zone. See, inside the earth, what is happening? That when that there is sudden shaking of the earth, so at some places, what is happening? That shaking is not felt due to the presence of some materials. So that shaking is not there. That shaking is not felt. That is known as shadow zone. During the earthquake, where the shaking is not felt, that is known as shadow zone. So inside the earth crust, we have that shadow zone of P wave from 103 degree to 142 degree. See, this is like this is 180 degree. So in this from here to 103 degree and 142 degree, we do not feel the earthquake. So this is known as the shadow zone of the P wave. And also in the both western side and the eastern side, both at the same, from here also 103 to 142 degree. So both sides we have 39 degree plus 39 degree, we have the shadow zone. So totally we have 78 degrees shadow zone in the P wave. So remember about the P wave shadow zone. So 103 to 142 degree, we have the shadow zone. So that totally, if we are including the both eastern and western hemisphere, so that is totally 78 degree. So totally 78 degree, we have the shadow zone of P wave. Then in secondary wave, what is happening? We have that shadow zone at 54 degree. Sorry, okay, this only we will cover tomorrow about the shadow zone. Then about the meshing earthquake we studied. Then about the meshing earthquake we studied. Then this is about the distribution of earthquake. So that is in circling that ring of fire area. Then where it is felt 68%. Then we have the in alpine belt, that is near to 12 to 12%. So that is about the distribution of earthquake. So okay, this is all about the earthquakes. So if any doubt in earthquakes, you can ask for me. See about the in secondary wave, what is happening? Now this is 180 degree. So what is happening when the secondary wave takes place? Then we have the shaking of the earth only till 103 degree, and after that to the like equator, you can say that to 180 degree, we don't have any shaking. So that is the shadow zone of the secondary wave. So in that total angle is 77 degree in the eastern hemisphere, and western hemisphere also we have the 77 degree. So 103 degree to 180 degree, we have the shadow zone of S wave, secondary wave. So that is the shadow zone of secondary wave. So totally we have 154 degree covering that shadow zone of the secondary wave. So this is all about the earthquake. So any doubt in the earthquake or the rock parts, any doubt, you can ask me. Okay, so we have finished this one. Tomorrow we will study about the plate tectonic theory, and then we will see about the geomorphic processes, that is weathering, erosion, and in that after that later class we'll see that landforms formed by the glaciers, mountains, all those landforms we'll see. So that's all for today. I'll say already I've shared the slide in the group, so just go through it and have the revision. So any doubt, anyone? Okay, so that's all for today. We are finishing up the class now.